Now you are going to use the virtual sequence in the example that you had described in the previous session. There we had three agents, an AXA master agent 1, an AXA master agent 2, and an OCP slave agent. And again thus we had three sequences, which are AXA master agent 1 sequencer, AXA master agent 2 sequencer, and the OCP slave sequencer. Now in the virtual sequence that we are going to define, we will be defining like class interconnect virtual sequence, which is extending from the UVM virtual sequence. So there is no such class existing called UVM virtual sequence. So you have to add a type def like this, which is casting the UVM sequence to the UVM virtual sequence. Next line is a factory registration macro, and the next important step is in the virtual sequence that you are going to define, you should have the handles to all the sequences in the environment. In our example, we had three agents, and therefore we should add the handles to the three different sequences which are sitting in these three agents. So there were two AXA master sequences and one OCP slave sequencer, which was sitting in the two AXA master agents and the OCP slave agents. Thus, we are declaring two AXA master sequencer handles like sequencer 1 handle and sequencer 2 handle, and the handle of the OCP slave sequencer. In the module method, you will be defining two AXA sequences and one OCP slave sequence. Like AXA sequence 1, AXA sequence 2, and OCP sequence. There's a small change in the content of this slide. There is a typo which I have corrected right now. Now, after creating the sequences using the factory registration macro, we will be starting the individual sequences in the respective sequences. So this is a master 1 sequencer, so we will be starting the AXA sequence 1 in the AXA master sequencer 1 handle, and in the other way we will be starting sequence 2 and OCP slave sequence in the respective sequencer handles. But you might be asking a question, how these will be actually starting into the original sequences, because these are just null pointers here in the virtual sequence, and you will see this dependency is handled in the test. Also, you can start the sequences in any way you want to start them. Either you can start all of them parallelly by using a fork join, or you can mix and match the way in which you want to start the sequences. Now see the test class. In the test class, you have the handle to the environment, or you will be instantiating the environment, and also you have to create the handle of the virtual sequence, which you had written right now. And in the build phase function, you will create this environment and the virtual sequence object using the factory registration macros. And in the run phase task, after raising the objection, you need to call a function called init virtual sequence. So this is a user defined name. You can give any name that you want. I have just given a meaningful name here, and look at this function. In this function, you will be filling the handles of the sequences in the virtual sequence with the actual handles. So in the test, we have the environment instantiated, and within the environment all the agents and thereby the sequences are sitting. Thus this test is a place where you should fill these handles of these virtual sequences with the actual handles of the sequences. Thus you will be filling like the virtual sequence dot AXI master sequencer 1 handle is equal to the interconnect env dot AXI master 1 agent handle dot AXI master sequencer handle, and in the same way you'll be filling the AXI master 2 sequencer handle and the OCP slave sequencer handle respectively. And I think this should clear your question of where these sequences are actually getting started. Once you have filled these handles with the actual handles, when the body of this particular new virtual sequence is called, this AXI sequence 1, AXI seq 1 will be getting started on the whole interconnect env dot master 1 dot sequencer, and the same way all other sequences will get started on the respective sequences. Thus you will be filling the handles in the virtual sequence with the actual sequencer handles in the whole environment. Now the next thing is to start the virtual sequence. If you remember, this was a syntax to start a sequence like seq.start, and as an argument you will be passing the path to the whole sequencer. And as this is a virtual sequence and there is no specific sequencer in which it should start, we will be calling the vSequence.start with a null argument. So when the vSequence.start is called, the body method of the virtual sequence is exercised, and this will eventually start the child sequences that we have started in the virtual sequence. Thus, when all of them are executed completely, or when the virtual sequence is completing, then you should drop the objection and your test is complete. Let me summarize you the concept of virtual sequence here again. The only difference by using a virtual sequence is that in the virtual sequence you need to declare the handles of all the sequences in your environment, and you will start the individual child sequences respectively in the corresponding sequences. And in the test, before starting the virtual sequence, you have to fill in the handles that we had already defined in the virtual sequence, that is the sequencer handles, with the actual sequencer handles in the environment.